Welcome to this lesson on plane mirrors, one of the fundamental topics in light and optics. Plane mirrors are flat reflective surfaces that we encounter every day. They are the simplest type of mirrors and serve as the foundation for understanding more complex optical systems. In this video, we will explore how plane mirrors work and how they create virtual images. A plane mirror is a flat, smooth, reflective surface that reflects light according to the law of reflection. The key word here is flat. Unlike curved mirrors, a plane mirror has no curvature. It is a perfectly flat surface coated with a reflective material, usually silver or aluminum. This flat surface allows light to reflect in a predictable and consistent manner, creating clear images without distortion. Plane mirrors follow the law of reflection, which has two important principles. First, the angle of incidence equals the angle of reflection. This means that when a light ray strikes the mirror at a certain angle, it bounces off at exactly the same angle. Second, the incident ray, the reflected ray, and the normal line all lie in the same plane. The normal is an imaginary line perpendicular to the mirror's surface at the point where the light strikes. Here we can see how reflection works at a plane mirror. The incident ray approaches the mirror and strikes its surface. At the point of contact, we draw a normal line perpendicular to the mirror. The angle between the incident ray and the normal is called the angle of incidence. Denoted as theta I, the reflected ray bounces off at the same angle on the opposite side of the normal. And this is called the angle of reflection, denoted as theta R according to the law of reflection. These two angles are always equal. A virtual image is formed when light rays appear to diverge from a point behind the mirror, but no actual light passes through that point. This is different from a real image, where light rays actually converge and pass through the image location. In a plane mirror, the reflected rays spread out, but if we extend them backward behind the mirror, they appear to meet at a specific point. Our eyes and brain interpret these rays as coming from behind the mirror, creating the illusion of an image in that location. When an object is placed in front of a plane mirror, light rays from the object strike the mirror and reflect according to the law of reflection. If we trace these reflected rays backward, they appear to converge at a point behind the mirror. This is where the virtual image forms. An important characteristic is that the image appears at the same distance behind the mirror as the object is in front of it. If the object is at distance d from the mirror, the image will also be at distance d behind the mirror. Images formed by plane mirrors have four distinct characteristics. First, the image is the same size as the object, meaning there is no magnification or reduction. Second, the image is upright, maintaining the same vertical orientation as the object. Third, the image is virtual, meaning it cannot be projected onto a screen because light does not actually pass through it. Fourth, the image is laterally inverted, which means left and right are reversed. This is why writing appears backward when viewed in a mirror. Let us look at the mathematical relationships for plane mirrors. The object distance, DO, equals the image distance. DI this tells us that the image appears as far behind the mirror as the object is in front of it. The magnification, denoted as M, equals +1. A magnification of 1 means the image size equals the object size. The positive sign indicates that the image is upright. These simple formulas make plane mirrors easy to analyze and predict their behavior in optical systems.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.